All right, everybody, welcome for data visualization. This is our latest track. We're going to be exploring how we can use programming to visualize data and get some insights into it. It can be super useful if you're trying to communicate your findings to your professor or to your client. And we're going to learn some awesome packages to do that. So hi there, Panda. Good to see you. I hope you're having a good Global Hack Week. Yeah. It's always good to get some feedback in the chat to know, yeah, am I the first one here? It's good to get some feedback in the chat because we know that people are watching. Hi there, Claw for Life. Good to see you. And yeah, I think we have some really exciting things for us to do today. So why don't we go ahead and get started? I'm going to upload a new slideshow presentation for the day. Let's see. Because we're starting a new track. We finished the algorithms, data structures, and algorithms track. And we're on to this new track of visualizations. So I need to actually upload some new slides. But while we're waiting, does anybody want to tell me if they've been to any streams today that they really liked so far? Let us know. We had some really fun times in the Discord. Me and Jocelyn, we were hosting a bunch of you who came and we played Scribble. I don't know if any of you are familiar with Scribble, but it's a Pictionary game. And you can do it with friends and guess different drawings, and it's a really fun time. Just say hi to some other people here. Pratik, hi there, and SheTech2, hi. Yeah, it's so good to see all of our community members logging on for a new track. And with no further ado, I want to post the check-in link. It's really important, everybody, that we get some check-ins. The reason because we want to actually, know, hey, are you all interested in the kinds of content that we're putting out here? And also for your own benefit, completing the check-ins helps you to gain more points in the league for the Global Hack Week standings. And you can actually go ahead and get some swag at the end if you post enough points. So I just highly recommend that. And we have some feedback from Panda. My feedback would be more clarity for the challenges. I understand that it is to let the imagination run wild, but it would be better if we could understand what the challenges meant in detail. For example, in Business Card Scanner, it goes from low level to high level programming based on what we make. Love to have better understanding of the challenge to work. Yeah, that's definitely something I can pass along to the team who designs the challenges. So I will definitely do that and make sure they know. Thanks for the feedback, Panda. And I'll post up on the screen here the link to check in for today if you haven't checked in already. But yeah, so for this first section, we're going to be introducing some fundamental concepts of data visualization. And we'll learn some basic plotting techniques using Matplotlib, which is a Python package. And we'll understand how to interpret and present our data effectively. Sorry about that, a little cut off there. And we will engage in hands-on exercises to reinforce learning. So here's a little outline for some things to do today. And we're going to go hunting for some real data on the internet. And I'll show you how to grab that and process it a little bit. And then we will use it to make some visualizations. So that'll be really a fun thing to do at the end. Yes, we're going to do a project where we visualize some temperature data, some global temperature data. So that's the answer to will we do a project at the end. And so what is data visualization? It's really important to know about data visualization. It has a lot of importance in data analysis. And it also has some real world applications. So some of those include, business analytics, scientific research, and things like that. And so we're going to now set up the environment that we'll need for using Matplotlib. And what I want you all to do is navigate to the following code link. I'll put it in the chat, code.visualstudio.com. And by going to this link, you can download Visual Studio Code, which is a great code editor to have for programming in Python. And I'll show you that in my window here. There it is. And I have on the left panel here, I could open a folder if I want to, or clone a Git repository or a GitHub repository. And then in this scratch paper here, we can have notebooks. So yeah, this is a Jupyter notebook that I've put up here. And so I'm going to be using Jupyter notebooks. As Penn said, I think data visualization notebooks are really good for that. So we're going to try to use them today. But we need to make sure that a few things are satisfied. So for example, we need to make sure that the required libraries are installed, and it includes Python and pip. So those must be installed, of course. And then once you have them installed, we will install Matplotlib and we'll install NumPy. So let me show you how to do that actually, because it's really a pretty important step. In this window here, I'm going to put a terminal in actually, so we can check the terminal as well. You can see this is my computer, and I have Conda installed, which is a virtual environment, and it helps me. I can see what packages are installed currently by typing conda list. So when I did that, I went ahead and listed all of the different libraries. All right, and so we can see that NumPy is installed over here. And so is Matplotlib. Should be up here somewhere. There it is, Matplotlib. So you're going to want to double check to make sure that the libraries you need are installed as well. Okay. So that will have to do it for those. And now we can move on to some of the things that we're going to do with Jupyter Notebook. So we're going to see how to launch it. If you don't use Visual Studio Code, you can actually launch Jupyter Notebook using the command Jupyter Space Notebook in your terminal. And so I've just gone through a little bit of the navigating the interface. And as far as creating a new notebook, you're going to use the extension .ipynb. All right, so that's how you create a Python notebook. Okay, let's go ahead and move on to the basics of Matplotlib. So I want you to first know about Matplotlib architecture. And a lot of people will get started with Matplotlib without first understanding these basic architectures. The first one is the figure. And the figure is the overall window or page that everything is drawn on. So when you have a panel that you create for your figure, that is put inside of the figure. You could also have a multi-panel figure where maybe you have, let's say, 2 by 2 panels, but the figure would hold them all together, okay? And you might also have some axes, which is the area where the data is plotted. So this would be a subplot within the figure. And so what you can type in is fig ax equals plt.subplots. Okay, and so you would type some arguments into subplots, but fig would be your figure and axes would be your axs here. So you might apply something to the whole figure, which could be like, oh, I want the figure to be 10 inches by 5 inches. But you might want to apply something specifically to an axis, like, for example, I want this axis to have an x-axis bound from 0 to 10. And then there's some other things you can do within the Matplotlib architecture, but these are the core things. And then the plot is the actual data representation. So it would be a line, a bar, some markers, a histogram, anything like that. All right. So we're going to get started by importing Matplotlib. And the way you do that is by basically just typing import matplotlib.pyplot as PLT. Okay. And when you run this, hopefully it should run the cell. And that indicates that Matplotlib was installed. Okay. And I want to start by plotting a really simple chart. So I'm going to start by saying, define some example data. Okay. And with this example data, it could be anything. I'm just going to type x equals 1, 2, 3, 4. All right. And then I'll type y equals 10, 20, 30, 40, just to be super simple about the data. Okay, so it's a pretty simple equation. It just means that y is 10 times x. Let's define that and run it. And now if we want to plot the data, we can use plt.plotx, y. And if we type plt.show, it's actually not necessary in this case because we could just type plt plot xy and it plots the data just fine. But plt show indicates to the terminal that we're done with this particular plot and this particular figure, essentially. So by typing plt.show, it sort of finalizes everything. And if we were to have some more data that we plot, we would need to type plt.show again, and it would plot actually in a separate panel, okay, not on the same one. Let me show you how that works a little bit. So let's say I had another cell here. And let's say it's x, comma, y, comma 2. And I'll do import numpy as np. Okay. Oh, sorry, I should write plot. So here's my second plot. This is going to be np.power means that we're going to talk about y squared. All right. And so, remove the sidebar? Sure, no problem to remove the sidebar. And I'll zoom in a little bit too. Hopefully that helps. But yeah, so this is plotting y squared now. But if we want to put these on the same plot, we can do so. So now they're both actually on the same figure. And actually, they're both on the same axis because you can see that the blue and the yellow are in the same panel. But if we type plt.show in between, you can see now they're actually on separate panels. So it's a little bit different when you do this. Okay, so let's go back to our slides now. And I want to show you how to make some different types of basic plots. So we did plot a really simple line chart, but I want to show you how now to make a line plot. So if you have a function that you're trying to represent, such as y equals sine x, let's just type that in the chat. You can do so in Matplotlib. And the best way probably that I know of is to use the linspace method. So when you use linspace, you're going to give it at least 2 arguments, probably 3 arguments. Actually, I think for linspace, you do need 3 arguments. There might be some default, but the first argument is the lower bound of linspace, just saying what the minimum value would be. The second argument is the maximum, so that's the 10 here. And the third argument is 100. That third argument tells you the number of points that you would like within the domain 0, 10. So that last point, here, let me show you that actually in the code. So let's do an example of that. We can do np linspace 0, 5, 10. And you see that first point is 0. And then that last point is 10. Those are the bounds that we asked for when we did the first and the second arguments. And then that third argument is telling us that we want 10 points, which will start at 0 and end at 5. So each one goes up by, well, it looks like about 0.56. All right, so that's basically how linspace works, and it's super convenient to use this when trying to plot some function because the x-axis will have just a uniform distribution of points. So let's try to plot that sine wave that we saw earlier. We'll use x equals to define np.linspace. And then we'll use y equals np.sine of x to just define the y values. So if we were to print out y, we get this funny looking list of numbers. But if we plot x versus y, you'll see that we have a sine wave. And you might be thinking, oh, this isn't really what I wanted to see. I wanted to see something that was a lot more, up and down and up and down, like a normal sine wave that you might see. Well, it's totally cool. If you prefer that, we can just increase argument number 2, which is that upper bound. So why don't we go up to 20, which is, let's see, almost 4 pi. So we should see about 3 cycles. Yep, and we see basically 3 cycles. And you might think to yourself, oh, this graph here looks pretty jagged. It doesn't even really remind me of a sine. And if you thought that to yourself, you'd be right. So what we can do to solve that is increase this third argument in the Lin space. So you just increase that as much as you want, let's say to 100. And already you can tell that is much closer to what we would think of as a sine function, right? So yeah, that's sort of how the line plot works. And then there's some other stuff we have here, which is sort of gravy on the top. So title, X label, and Y label. And we can assign those using PLT. Oh, sorry. Panda said, why did it change again? I'm sorry. Can you repeat the sign? Yeah, definitely. It changed because we altered the third argument here. So with 10, what that does is it creates 10 points, Lin space does, between 0 and 20. So that's going to be very jagged. And if we increase 10 to 100 points, we get it's basically just a much more high definition picture of the graph. Right now it looks really a lot like sine. And if we decrease this 20 to 5, let's say, it'll just show a more limited view of the domain of the sine function. All right, so hopefully that is a little bit clarifying, but we're going to add to this picture. So plt.plot, it creates a plot of data, and in this case, a line of data, or a curve, you should say, really, on the default figure and the default axis, in fact. So there is this default axis that we already have when we just run that plot code. And we can then edit the figure by just typing PLT again, and we can add a title. So let's just call this sine wave. And we can add some X label and some Y label to this data. And these PLTs, they're acting on the most recent axis that had some data plotted there. So we know that PLT plot plotted the data on this axis here. So we would expect that then the application of these titles and labels will also occur on this panel. So when we run, you can see that it applied all of the relevant labels and titles. Okay, so that's kind of cool, kind of a cool result. And now I wanted to put another problem, which is plotting a cosine wave. So it's essentially the same thing. But yeah, you just want to try to use appropriate labels and a title. So you would just edit the title to say cosine wave and keep everything else the same, except you could change the plot. And actually, I'd be curious to see if we can plot these on the same. So let's try to plot them on the same. Does anyone know how to do this? Because we did discuss it in the beginning, how you would actually plot two lines on the same panel. Yeah, so Panda says introduce a third variable z. I think that's a good idea. And then we'll just make another plt.plot. So we'll just call this cosine x. And we can just add another plt.plot directly underneath the first one. And they'll actually plot together. If we were to then do plt.show here, that won't work. It'll actually produce two separate plots, as you can see. And notice that the title and the X label and the Y label, they all got applied to that last panel, the most recently generated axis. So whatever was that very last axis to get created, it will do that. And Panda says, do plot Y and Z, and it makes a circle. That's a good idea. Let's do that. But let's do that on a separate. So we have these two. And if we then plot a separate one, we would want to type plt.show because it's going to be on a separate panel. And let's give it some title. We can call it the circle. It's actually a unit circle, but we'll just call it that for now. And the X label, on the X label, I'll just call that sine. And on the Y label, I'll call that cosine. Okay, so there it is. And does anybody know why it didn't plot a full circle based on our code? And what we would need to change for it to plot the full circle? It's a math question for you. Nobody knows. We have 20 people here. Yeah. Yeah. So Panda says, is it because of linspace is only putting 5 points? So just remember, linspace is actually putting 10 points because the third argument tells how many points to put. So let's try to increase that linspace and see. I mean, if we increase that third argument and put, let's say, 100,000 points and run, we still don't really complete that circle. I'm going to actually call this a unit circle. Maybe that will give it away a little bit more. But essentially, the unit circle starts at 0 and does a full rotation at 2 pi. And we can actually replace 5 with 2 pi. If I just print out what 2 pi looks like using the np.pi built in, 2 pi goes to 6.28 roughly, which is a little bit more than 5. So 5 brings us almost all the way around the unit circle, but not quite. So once we type 2 times np.pi, we get a full unit circle. And yeah, 20 would work too. If you did 0, 20, 100, it would work. That's 100% true. And it's because 20 would actually bring you more than one revolution around the circle. It would bring you probably almost 4 revolutions around the circle. All right, so that's a great example for us to check. And I want to now talk about an example where we're going to plot some scatter plot. So up until now, we've been doing lines or curves, I guess you could really say would be the appropriate way to describe them. But why don't we try a scatter plot? And they're used for displaying values for typically 2 variables for a set of data. So, with plot, we could actually plot 1 variable But with scatterplot, it's really not going to like that. Let me show you what I mean. So in plot, you can actually just plot plt.plot y, and that will work. It will plot on the x-axis. It'll plot the index of the list that you pass into the plot method. But scatter will really not like this. Scatter will really want you to have both an x and a y. So let's take a look at scatter here. To basically call that, you type plt.scatter, and then the x-axis coordinates in a Python list, and the y-axis coordinates in a Python list, also in a Python list. And then you can just add some title, some x-axis, some y-axis, and then show that. So let's actually do that example. So we see that x could be equal to 5, 7, 8, 7, 2, 17, 2, 9, 99, 86, 87, 88, 111, 86, 103, 87. And to do scatter plots, we would type plt.scatter and then x, comma, y. So now when we run that, we get the scatter plot. That's kind of an interesting picture. It almost looks like it's declining. As you increase x, y tends to decline. All right, so we can even add a title here, just like we did for the earlier plots. Some x and y labels and just some show to give it a little bit of a nicer tune. And one thing that people don't always realize is that we can change the default text on here. So I want to do that. Let me quickly check that reference. Okay, so here's what I meant to do. I'm going to introduce something here called the font size. So what we'll do is actually type comma font size equals 12. After all of these, you can see it increased the size. We could even increase the title more than the axis labels. A lot of people will like to do that. They'll say, oh, I'll put the title really big so that it's easily identified and kind of your mind's eye is drawn to it. But there's another way to do this that I don't see implemented as much. And, doing it this way is really annoying if you put a lot of different PLT statements. Just don't bother with typing font size all the time. Instead, what I'll tend to do is, if you remember, we did import matplotlib.pyplot_splt. After that statement, sometimes what I'll write is plt, so we'll write plt.rc params, and this is telling us some core parameter of the matplotlib library. So we're going to actually edit the font size, and we use these brackets to give some keyword arguments to this update method. Oh, I forgot to write .update. That's really important. So When we give a keyword argument, it will update that for the default for all PLTs. So what I'm going to give it is something called font.size, and I can set that to 12 by default. So now when I run this code, and I run the next one, the default value for these titles and X and Y axis labels is in fact 12. And I could easily increase that to, let's say, 16. But it won't change the other two. So this is a great way to just implement something across the whole entire plot, and then you don't have to worry about adding it back. You can see it even increased the font size on the axes, on the like 105, 100, 90. So that's also a really good benefit. People will, compliment you on your plot because they're always used to seeing these really tiny axis labels that people create for their plots in Matplotlib. And once you show them this, they'll never look back. So there's a tip for you. And another one you can do to make your plots look more professional is you can actually change the figure size too to make it smaller. So here's just an example, 10 by 8. That's a really big figure. You can make it smaller, like let's say 5 by 4. And there's a much smaller figure. So those axis labels look bigger now than they even did before, just because the figure size has changed. So what you want to do to really emphasize those labels, you can either increase the font size or decrease the figure size. And you might have reasons for doing either one, but usually some combination of the two is the best. And okay, so let's keep going. We're going to move on from scatter plots, and we're going to plot some random data. And sometimes you will actually want to plot random data if you're just trying to test something out and just see if it works. So here our problem is to plot random data points, and we're going to generate two arrays of 50 random numbers each. And they're going to be between 0 and 100. And we will create a scatter plot of these numbers below. And we'll just use some different colors and some different markers, which we can easily do with Matplotlib. It's really nice how it's implemented. So let's get started with that. We're going to go into our code editor, and just as I showed, we will start by creating these random numbers. And earlier we were generating these by hand. You could see we just kind of generated some, well, not random numbers, but whatever numbers we could think of for X and Y. But now we're going to say X equals np.random. So random is this library that can give you random numbers in your Python program. And so we're going to call the method randint, which gives random integers, and it gives them specifically between 0 and 100, basically the first and the second arguments in the randint. And it'll give 50 of them. So it's really similar to how linspace worked. But this time, instead of creating a linearly spaced elements like linspace does, it'll create totally random integer elements for these X and Y data. So if we do the same for Y, we can now produce a scatter plot. which remember gives us two different dimensions of data. And so we'll just type plt.scatter x, y, c equals red, and marker equals x. And this C is referring to the color of the marker, whereas the X refers to the marker itself. In the default case, the C is that blue color that we had in the previous figure. And the marker is that filled in circle that we had. But we can, of course, play around with those. And so C is now set to red and marker is set to an X shape. So when I run this code, you see a really jumble of these. And notice also that the figure size and the font size are exactly the same as the previous figure. And what that indicates is that when you run this code to update the parameter for matplotlib, you only need to do that once. And once you do it, it will apply to all of the codes that you then write in your Python notebook. So it's really useful to do it this way. We would not want to just constantly be having to tack font size onto everything. So yeah, there it is, our random data, and we could even plot it again. And every time we plot, we should see a new picture. It's actually kind of mesmerizing to look at it and see all the different patterns. It kind of looks like snow to me. But yeah, thank you all for sticking around for this one. And we're going to actually now just add a few titles here, like random data, random scatter data. That's a good idea. And just give it some x-axis, y-axis, plt.show. And you can really see the random data. All right. So now we'll move on to another example, which is going to be bar charts. So bar charts are another plot type that you can create with matplotlib, and they're really useful for comparing quantities among different categories. And so categories, by definition, those are things that don't have some specific number to them. So in the past, we were using scatter, and we had to put on the x-axis some number, right? Even if it was random, that would be fine, but we need some number on the x-axis so that we can build our tick labels and do all that stuff for a scatter plot. But for the case of the bar chart, we're actually interested more in getting some categories. So the categories are typically strings or characters or numbers. They could really be anything, but they're discrete. And by discrete, I mean that, you know, it's either A or it's B. It's not in between, right? There's really nothing in between. So we would type categories equals ABCD, and then the values that we want to associate with those. Typically, these values would be some kind of frequency. So A might mean that you have 5 A's, for example, and B might mean that you have 7 B's in some, some text that you're reading. And so to plot this, we use plt.bar, and the category data goes into the first argument, and the values go into the second. So the values we could also call the frequencies. And why don't we go ahead and implement this? So we would just type categories equals A, B, C, D, and values equals, let's say, 5, 7, 3, and 4. And then we can type plt.bar categories and values, and I'll add in a few of these titles and labels as we did before. But yeah, let's run that code, and you can see the bar chart comes out really nicely. Okay, so that is one great way to make a bar chart in Matplotlib. And we're going to actually plot, we're going to do a exercise ourselves next. So I'm going to give you some instructions in the chat, and I'm going to paste them into the code here too. And I want you to try this on your own, since we've learned a little bit about data visualization. I want you to try to create a bar chart knowing this information. I'm just going to make it kind of nice in Markdown. That the 4 majors at the university are engineering, arts, science, and business. The number of students are 120, 80, 150, and 100. I want you to create a bar chart with the appropriate labels and title. And so why don't you go ahead and try to do this on your own for just about 2 minutes we'll take for that. All right, so hopefully you had some time to think about that on your own. And in fact, I'm just going to use this data to update my old bar chart example. So from the categories, I'll just change that to be engineering. Now, let's see, we had arts, we had science, and we had business. So those would be those 4 categories. And then we want to type in the values. Remember, I said these are typically frequencies. So it could be just number of students in each major. So for engineering, it was that we had 120 students. For arts, it was 80. And for science, it was 150. And then for business, it was 100. So after putting those in, we could then change the title. Let's just change it to students in each major. And we could change the x-axis to major. And I'll just change the y-axis to number of students. So we run that, and here's what it looks like to have all 4 of them. I think this is actually a little bit crowded, because you can see the engineering and the science are kind of crowding into arts and business respectively. So why don't we tone down this a little bit? Or maybe we'll just increase the figure width by 1 inch. If we do that, let's see. Yeah, that looks a lot better. So you can play around with things like that, and if you see too much spacing, it can be a good way to change it. Right, getting some thumbs up here from Panda, so that's very encouraging to see. All right, now let's go ahead and do another one. So we finished this exercise where we plotted the student numbers by major, but I want to show you how to customize the plots a little bit. So one thing you can always do is add grid lines to your plot, and doing so is fairly simple with matplotlib. You would type what's called plt.grid, and then inside you pass the argument true. So let's try to do that. I think for the bar chart, we should be able to. Yeah, so we can pass grids into the bar chart to see, how large is 100. Well, 100 goes up to here, right? So certain bars meet 100, certain bars don't. And that's a really great feature to know about, is adding grid lines. And then here's how you can change line styles and color. So we talked a little bit about color already, and we used the keyword C, but the keyword color also works for changing the color of a plot. And so we used color equals green in this plt.plot example. And then for the line, we had line style equals dash dash. So that would actually create a dashed line. And then line width tells us how thick the line will be. So line width equals 2 is actually quite thin. Well, actually, I guess it depends on a lot of different things. So why don't we just plot this out and we'll see what it looks like. I'm going to use our sine curve as an example. Okay, so let's scroll back up to our sine curve. There it is, beautiful sine. And let's say we wanted to update this code here to have line style dash dash for the x comma y. So now we expect this blue line to be dashed, and indeed it is. But let's keep the other one solid, and we'll use line width, just like they did in the example. We'll set that equal to 2. All right, so you see the line width gets a little bit bigger. We could even, so I guess here it's actually line width equals 2 would be quite thick. And we can even up that to line width equals 5, and you see a really, really big difference. Okay, so those are just a few of the other customizations that can be done. And then here we'll add legends. So adding legends is pretty straightforward. You basically can put a label on any plot that is produced for the matplotlib figure, and that associates whatever data is plotted with some label. You might ask, why do I care? Why would I want to associate my data with a label? Well, the reason is that in the end, you can create a legend where each label is sort of assigned to what it looks like in the plot. And let's give this an example by labeling the sine and the cosine. So we did already plot them out, and why don't we just type label equals, I guess this one would be sine, and this one here, label equals cosine. All right, so when you run it, actually nothing happens, maybe unsurprisingly, or maybe surprisingly. I'm not sure whether you were surprised by that, but if we type plt.legend at the end, it will compile all the information from the labels above it and generate a legend. So when we run this, you can see sine and cosine are in the panel, and they're actually showing very correctly with a very high level of accuracy which curve is which. And the legend, one tip for the legend, you can make it go wherever you want. So we can actually change the location to center right, let's just say. And there, that's center right. We could also change it to lower right, where it goes into the bottom. So that's sort of the idea with the legend. And now I want to have this multi-line plot comparison where we're going to plot 3 different things, use 3 different colors, 3 different line styles, add a legend, label, and title. Why don't you all try to do it for about 2 minutes, and then we'll go over it together. Okay, hopefully you were able to try that out for yourself. But if not, we're going to actually do it together now. So let me open up the code editor. Oh, we've done a lot of plots. Okay. And we'll do some more. So here we can just have a new cell in Python. And we're going to start by defining each of these curves. And just remember back to when we did the sine curve, all right? And what we did for that. So we did a little bit of linspace. And so we'll just say, well, we don't need to do the imports again, but we'll just do linspace 0, 5, 100 like we did before. But the curves are a little bit different this time. So y1 is going to be x, which is just a really simple linear curve. And then y2 is going to be x squared. So this double asterisk means that we're raising to the power of 2. So the exponent is squared. And then y3 is x cubed. All right, so that's the 3 curves. And then we can plot them. So we'll use plt.plot, just like we did for the sine curve, for example. And we'll give each one a label. And I want to give them each a distinct line style. So the first one, I'll just make it solid. And the way you do solid is just through 1 dash. Okay. And how about we make its color blue? Okay. And then I'll do another one. Sure, why not? Copilot. We could do dashed and red. And then the third one, you'll notice that the line style is dash dot. And what that means is it's actually going to alternate between dots and dashes when it plots the curve. So we'll get to see that in action right away. So let's just do a quick title here, comparing x squared, x third, and give it some quick labels like x-axis, y-axis, the y-axis next, and we'll give it some legend. Let's put the grids on, why not? And we'll type show too, just to be very official about it. And here are the 3 different curves. You can see how they evolved and how there's even a label associated with each one so that the legend can plot to, right? So that's sort of our little exercise here. And now we're going to get to our project, which is working with real data. And I think this will be very exciting because we'll actually get to do some real data project. So I'm going to have us look at a global temperatures data set, and it's going to be global temperature anomalies from NOAA, which is a U.S. science agency, and we will see how the temperatures on Earth are changing every year. So Panda's certainly very excited for a project. That'll be really fun. So why don't we get to it, everybody? We're going to use the global temperature record. All right, here is the page. I posted the link in the chat. And let me plot as well. Or sorry, let me just visualize this as well. I'll just so that I can share my screen and show it with all of you. So this is a really neat visualization that NOAA has created. And a lot of the times, some people will say they don't believe in climate change, but we can actually make this plot ourselves using the data. So why don't we download this data? We'll go back as far as we possibly can. So let's see how far we can go back. I want the average temperature anomaly. I want 1 month. I'll just take the year to date. I don't need the monthly data, although the monthly data would be interesting to look at too. But for now, let's just use the year to date. And then we'll start with the month September, I guess. Why not? And we can start in 1850. That's a long time ago. And end in 2024. So that's, what is that? Almost 200 years of data. Not quite, but almost 200 years of data. And we can even choose the region. So I encourage you to choose the region that you live in. Here, I'm going to choose North America because that's where I live. And I guess if you want, you could even choose a latitude and longitude to be very specific. But I'm just going to plot. And we can download the data here in this table. So here's my data for every year.
So I'm going to click CSV to download that. So I just downloaded the CSV. And actually, this is a very small data, just to let you know, Panda. This data set that I just downloaded is only 1 kilobyte. It's only about 200 numbers. So you won't need a really advanced computer for it. But yeah, feel free to follow along with a smaller data set if you want. Okay, so remember these temperatures you're looking at are all in reference to a mean from 1910 to 2000. All right, so that's going to be our reference point. And so, of course, the temperature in North America is not 2 degrees Celsius. It's 2 degrees Celsius relative to this mean result in the last century. All right, so why don't we now try to import this into our code, and we're going to use what's called pandas to import this CSV. So pandas is a library that can be used to read in a CSV file into your Python. And the way that it outputs the data is as a pandas data table, which can have columns, rows. You can do operations on it, and you can even visualize with it. So why don't we import with pandas? Go into my VS Code. There's the scratch. And I'm gonna actually make a new coding block here. And I'm gonna say, all right, down here, oh, maybe I'll just delete this. But down here, we're gonna do import pandas as PD. And we'll say pd.readcsv. And I think it should be in the following place. It's called data.csv. Oh, I think I need to capitalize downloads maybe. All right, let me try to find this thing. It's definitely here. I just need to find the little path. Oh, let's just do the direct path instead of a relative path. Sometimes these drive me nuts. Yeah, Panda. We're doing Panda. That's so good for Panda. Of course you're happy about that, huh? That's awesome. But yeah, so we're gonna I just copied the direct path. Oh, it seems to be having some issues. So let's actually investigate this data.csv. I never ran into this issue before. All right. So here it is in Excel. And sometimes they get upset about, you know, having some extra stuff at the beginning. So here we have 1, 2, 3, 4, 5. Row 5 is where we actually get some data, meaning we get the names of the columns. And in the beginning, they're just basically defining the data set and saying what's the name of the data set, what are the units, the period, things like that. So instead, why don't we go ahead and skip these? And there's a way we can do that in Read CSV. The way we do it is we use something called skip rows. All right, so we're going to skip how many rows here? 1, 2, 3, 4. 4 rows. I think should be it. So let's try to skip 4 rows in our coding Scratch. If we were able to do it, we could just type here, skip rows 4. Worked. Amazing. So that worked, and now we have our data, and I'm going to save it to the variable name df, because df is standing for data frame, and that's again what we work with when we import a pandas CSV. We work with a data frame. And so if we wanted to only see the column which has the year in it, we could just type df and then the following, hard braces, and then quotes, in quotes, year. Okay, so if I just run this now, it shows me every year from 1910 all the way to 2024. And if I were to type anomaly instead, it just shows me all the anomalies. So why don't we say that x would be equal to df year, and y would be equal to df anomaly. If we type plt plot x comma y, it should show us the temperature over time. So there's the temperature over time for the North America continent. And I'm going to take a pause because it seems like Panda in the chat is getting some parser error, presumably with the pandas. But did you try doing the skip rows command? You might need to type skip rows equals 4, so that you can basically skip over all that metadata that occurs at the beginning. I'm not sure if that's going to solve the problem for you, but hopefully it will. All right, and I actually kind of like how the other one, the NOAA visualization was, where red was anything above 0 was colored red, and anything below 0 was colored blue. So why don't we try that out? I'm going to actually say that we're going to put it into 2 different variables. We'll have x above 0 and x below 0. And then we'll say y above 0 and y below 0. And we'll just say that this is for any year where the anomaly was bigger than 0. And conversely, of course, this below 0 metric would be any year where the anomaly was above 0 and below 0 here. So let's try plotting these. We could plot x above 0 and y above 0. I'm actually going to try plotting scatter. Oh, that didn't really work. Just plot the blue. All right. And we can also plot below 0. And so we can see that most of the above 0 points are occurring towards the end of the year. And that's what's causing the anomaly. Anirudh says, is this Visual Studio? Yes, it is. So I love using Visual Studio for Python notebooks like this one. Geez, I don't think this looks very good, honestly, this this breakdown. I thought, oh, maybe I'll try to do this, but yeah, I think maybe we'll try to do that. So let's try to do that. So let's just go back to X and Y. So here's what it looks like. And the goal is so that anytime it passes over 0, we would see some kind of change. And yeah, maybe I'll use some sort of conditional statement to change the coloring. That's kind of why I wanted to use scatter points, though, because they would give you that change in the coloring. Why don't we just plot a scatter plot of any time that the temperature goes above red, above 0, we'll plot that as red. And we'll just plot that as x's. So we'll say this is wherever y is greater than 0. Let's see how that looks. It might look a little better. Yeah, that looks a lot better. So that's kind of a cool metric. And we can really see how it changes over time. So by the end of the record, every single year is above this average, not just the unusually hot years. And I'll even give another thing here, which I'm just going to put. It's called AX-H line, which is X horizontal line. And we'll just make it a very thin black line so that folks can see the trend. And if you want, you can add some title for your region, because your region might not be North America, but I'm going to put my region as North America. And maybe I'll put some line on the x-axis labels, the y-axis label. Yeah, I don't think I need year on the x-axis. It's kind of obvious, right, that this would be the year. But yeah, so why don't you share your plot if you made one? Feel free to share it with us in the Discord. I'll put mine in just the little hack together thread. So please feel free to post your data visualization. But yeah, I think that's what we have for the day. So we did a hands-on exercise. Oh, we have a little bit more to do. I just wanted to show you one last thing, which is histograms. So why don't we cover histograms before we finish? So they show the distribution of numerical data, and it's a little bit different than those bar charts we were looking at. Those bar charts, if you remember, they were categorical. Oh yeah, no problem. Thank you, Panda, for sticking around. You're awesome. Okay. And so we can do a little histogram together. I have actually an example here. So given some test scores for the class, let's create a histogram to show the distribution. And we could use bins of 10. So it's similar to a bar chart in the sense that you have categories. But those categories are defined by lower bound and upper bound. Oh, yes, I'm happy to share my LinkedIn for anybody who wants that. I hope it works. I just typing it off my memory. Let's see. I'm just gonna double check it right now to make sure that it works. Doesn't go to some random person. Oh, that didn't work. Okay, hang on 1 second. Give you guys a broken link. All right, it's actually not that. It's here it is. Thank you, everybody, for your patience on that. But yes, I'm totally happy to connect with anyone on the LinkedIn. So our histogram here, we can just type out our scores. So actually, I'm just going to copy the scores and the bins from the example. And then I'll just type, it's really simple. You really just type plt.hist and then scores and bins. And if you run that, you get this sort of blob here. And if we type edge color, it'll show edges around the histogram. So it's sort of like a bar chart, but things are connected because if you'll remember what I said about bar charts is that it's not possible to make a bar chart with continuous data. It's only made with discrete data. But a histogram, you could have continuous data and you just bin it up in these bins and then it becomes discrete because it could only be part of one bin or the other. And Anirudh said, can you please share the Discord channel? Yes, of course. So the Discord channel is https://discord.mlh.io. And that will invite you to our community on Discord. And yeah, please post your temperature curve if you have one. And there's a chat called Hack Together that you can do it in. I would be super interested to see yours. Okay, let's keep going here. I have one more that I wanted to try, which is creating pie charts. So this is another way to do categorical data. And it represents parts of a whole. So if you have something where, it's a whole and then you want to divide it into different categories, this could be a great way. So I've just pasted the code example, and why don't we take a look in Visual Studio Code to see what it really looks like. So the pie chart would be, let's just say we write slices equals 7, 2 to 13. And then the activities are sleeping, eating, working, and playing. So these might just be some hours of the day that you spend doing things. It's a good thing you spend so much time playing. That's the way I want to live. And then we can give some colors if we want to really just make sure that they know what colors we should use to represent. And then this is one of my favorites. You just type plt.py. And you can add slices, some labels for the different activities, the colors, and there it is. There's our plot. It actually looks kind of dark on the background, so I actually think I might want to, I think if I go like this, maybe I just add this into here. Looking tough here. Oh, there it is. Okay, so yeah, I just added this face color equals W because it's kind of hard to see on my panel here, but you can see that. Maybe I'll add something a little bit better than that and not so white, but that would be really good to do. And so I'm going to keep working on that. And the idea here is to make sure that everything is going to be in the right color scheme. And then you go ahead and add some title. And show the plot. And so that's pretty much all I had for today. I just wanted to show you some of these awesome visualizations that we can do. But yeah, that's all for today. And next time we will do them. And Anurad says, how do you remember the hyperparameters by heart? I know, right? They're so hard to remember to get them all right. It's just many times of trial and error to finally get them. You will too if you do lots of visualizations. And now we have ChatGPT, which is awesome. You can just describe what you want to ChatGPT and it will find all of these hyperparameters for you. But yeah, those are always great. So, all right. Thank you for all that. And yeah, hope you all have a great rest of your day. We'll have another part tomorrow.